Hello, chemistry students. We will continue today our equilibrium unit, and we're going to talk about how we can predict solubility. Essentially, what we're doing here is we're combining two concepts, two previously covered concepts. We're going to look at what Q represents. Again, we know that Q is your reaction quotient, right? And this expression represents the concentrations of reactants and products, perhaps not at equilibrium. Perhaps it is, perhaps it's not. So that's your reaction quotient. But we've been talking more recently about KSP, your equilibrium constant for heterogeneous solutions, specifically a solute dissolving in a solvent. Now, if we don't know if a solution is at equilibrium, in other words, we don't know if it's saturated, unsaturated, or supersaturated, we're going to then say, given concentrations or determined concentrations, we're going to say that QSP is then what we will use to instead of KSP when we're not sure if it is at equilibrium. And again, like before, you can compare QSP to KSP. It can be less than, it can be greater than, or it can be equal to. Okay, we'll look at what each of these scenarios would represent. Remembering, though, that a heterogeneous solution, let's say solute AB, will dissociate or ionize in this case to produce A and B, right? And we know our QSP or our KSP expression is just, and we would have to then ignore AB because it is a solid and we don't put anything in our denominator. Now we know that the going forward is going to solubilize, going backwards it's going to crystallize. Okay, so a bit of review. And here's a question that we probably already answered. When you're not sure if equilibrium is reached and concentration values measured, what constant do we use? So hopefully you're thinking it's Q. Okay, but specific to solubility, we're going to say QSP. Okay, a few tidbits. Already talked about a lot of this. Again, when you don't know if it has reached equilibrium, then we say Q. When it refers specifically to a solute and solvent, we say QSP. Okay, so here are our different situations. So if QSP is less than KSP, okay, that means QSP is smaller than KSP. It can go in the forward direction. In other words, there's room now for those concentrations of those ions on your product side to increase. So if that's possible, then the right or the forward reaction is going to be favored. Meaning if more solute can dissociate or ionize, then it is an unsaturated solution. And more salt can therefore dissolve without a precipitate forming. But now if they're both equal, then you have reached equilibrium and so it is saturated. Right? In which case, no more salt can dissolve. Now, if QSP is greater than KSP, then those concentrations of your products are more than they should be. That means that you have a supersaturated solution, and according to the Chatelier, you're going to then move to the left to compensate for that, and you'll get a precipitate forming at the bottom or wherever, I guess, depending on the density, until QSP equals KSP. Okay, so those are our three scenarios. Student 1 said, referring specifically to KSP, so you can think of KSP as the equilibrium constant for the saturation point of a solute. I thought that was really well put. I'll keep that student's identity anonymous right now, but that was really well put, so I thought I should share that with you. Okay, first example. Now I'm going to switch because sometimes my pen lags if I do it here. So here's the situation. I will go over the question first before I do that. Okay, let's use green. So it says, predict whether a precipitate of silver chloride will form in a solution containing silver at that concentration, silver ions at that concentration, and chloride ions at that concentration. And look, it gives you KSP. Okay, I think you know enough for you to solve this yourself. Okay, so if you want that challenge, you can pause the video and go ahead and do that. Otherwise, we're going to continue now to solve this. Okay, you know, if we were in class, that would definitely be something you would be doing right now. So example 1. Okay, now this is what is given to us. So concentration of silver is 1 × 10⁻⁵ moles per liter, and the concentration of your chloride ions is 1.0, that's a point there, times 10 to the negative 4 moles per liter. All right, now what the question I don't think gives us, I can toggle back to that, it doesn't, which is fine. What it doesn't give us is the dissociation here. Okay, silver chloride is going to dissociate, fortunately for us, although it wouldn't be too much difficult or more challenging if it wasn't. It dissociates in a 1 to 1 ratio. So that means our QSP, right, our QSP expression will look like this. Right? Okay, now we know these values, it's given to us in the question, so let's just plug them in. We're going to ignore units. We've already talked about why we're going to ignore units. We know that this is a concentration, though. Don't usually ignore units. We just spent a while talking about why, previous to this unit, why we shouldn't, but we're going to for now. Okay, so what you get is, look, 1 times 1 is 1. Add the exponents here, a bit of, I believe that's grade 9 math. So we get 1.0 times 10 to the negative 9. Okay, now this is our QSP value. Again, that's our QSP value. I'm going to toggle back. The question gives us KSP at 1.8 times 10 to the negative 10. So now we have to compare. Is QSP greater than, less than, or equal to KSP? Again, KSP is 1.8 times 10 to the negative 10. 1.8 times 10 to the negative 10 is our given KSP. So let's compare. This number is greater, right? Has a lower value for that negative exponent, so we're going to say it's greater. Now, because of that, we're going to answer the question now and say that so therefore, a precipitate of silver chloride will in fact form. And that's it, and you're done. That's question 1. Okay, question 2. I'm actually confident that you can do this yourself, but let's do this together. Okay, I'm going to need some room, so I'm going to start a new page. Okay, let's go over this. Let's understand this question first. Okay, green. Will a precipitate of calcium sulfate? Okay, now calcium sulfate, let's write that down. Calcium sulfate. Will that form? Okay, if 50 mils, 50 mils of that molar concentration of calcium chloride. Okay, so we have something going on here. We have calcium chloride. We know the concentration. And we have volume of calcium. Oh, I'm missing something here. Okay, and the volume we know of calcium chloride to be 50 mils. Convert that might as well to liters. Okay, so that's happening. Right, so if that solution, the calcium chloride solution, were added to sodium sulfate, okay, now there's sodium sulfate, and that looks like that. Sodium sulfate has a concentration given to you. Fortunately, look, it happens to be, oh, not the same, thought it was. It's going to be slightly different. So it's 0.0, not slightly, I suppose it's a over 1 decimal place, so it is quite different. 0.01 molar concentration. And what is the same, though, is the volume. Okay, so I'm going to just convert that right away. Okay, we have that many liters. Okay, so will then, by adding these two solutions, right, solution 1, solution 2, will a precipitate of calcium sulfate form? Okay, and it gives us a KSP value of calcium sulfate at that. I think you can figure this out. You have all of the all of the background knowledge to figure this out, but you know, it is quite challenging not having done a question like this. This is called a double dilution question. It is also similar to something we will do in a couple of days called a common ion, but we'll get to that later. So the answer is here in case you do want to give it a try, but I am going to go over it now. This would be a question that I would not ask you to do by yourselves. Maybe just perhaps get started on. Okay, let's switch. So given all of our knowns, okay, when you combine, I'm going to write some of that again. When you combine calcium chloride and sodium sulfate, both aqueous, when you combine them, what's happening is you have 50 mils of each to get 100 mils, or 0.1 liters. This is a dilution, right? You are diluting each of these solutions by combining them by increasing their volume. So hence our double dilution. So let's use our dilution formula from grade 11. C1V1 is equal to C2V2. We want to know the new concentration of our calcium chloride. So we're going to solve for C2, right? That new concentration. We know everything else. We know the initial volume, we know the new volume, and we know the initial concentration. So C2 is C1 V1 over V2. And then go ahead and plug things in. Okay, notice liters cancels out as they should. Do a little bit of math in your calculator and you get, there you go. That's a concentration of calcium chloride. Let's do the same thing for sodium sulfate. Okay, C2 is equal to C1V1 over V2. We know the initial concentration of sodium sulfate that's given to us. We know the initial volume, that's 50 mils. We now also know the new volume, so we can plug all of these things in. And we get 0.01. That's a 1. And again, liters cancels out. And we get 0.005 moles per liter, which is just big M, molarity. Okay, so now that we know the concentration, the new concentrations of both calcium chloride and sodium sulfate, we have to consider something. Look, when calcium chloride's in solution, you know what, I think I will take advantage of these different colors here. Let's choose, that was the background stuff, let's choose a different color now for calcium chloride. Okay, so calcium chloride will dissociate. Okay, and it dissociates like this. Okay, and remember that there is a 2 coefficient. Done. Right, sodium, different color, sodium sulfate dissociates like this. Gave myself a little bit less room here. Right, and then 1 sulfate. Okay. So what we figured out is we know the concentration. We know the concentration of calcium chloride. Okay, using this 1 to 1 to 2 stoichiometric ratio, we can then say that these are the concentrations of each of the resulting ions. Now, to get to this, again, all you need to do was multiply by 2 because of the 1 to 2, right, since it's a 1 to 2 ratio. Okay, so now we know the concentration of chloride. There we go. So before I move on, the question's asking, will calcium sulfate form a precipitate? Okay, yes, we figured out what chloride is, but this actually isn't really relevant. Let's take out the red here. It's asking for calcium. Will calcium sulfate form? So we're going to get a calcium ion from this solution, and your sulfate ends up coming from here. So whatever this value is, we need to figure that out. Okay, so let's do the same thing now for our second solution. We figured out the concentration after dilution. It's that. Now it's a 1 to 2 to 1 ratio. And we can even ignore this, although you might as well fill it in. You don't have to, but this is a 1 to 1 ratio between sodium sulfate and sulfate, so 1 to 1. So since it's 1 to 1, we can just write the same thing. Okay, so that's a concentration. And this is what we need. We need the concentration of sulfate, and we need the concentration of calcium to figure out calcium sulfate. Okay, back to different color. Okay, so this is what is really happening here. We have what we're really testing for. Calcium sulfate. That dissociates, looks like this. Okay, fortunately it's all the 1-to-1 ratio. So if we're going to test if calcium sulfate forms a precipitate, then we need an expression for this. Instead of KSP, since we don't know if it's at equilibrium, we have to write QSP. And that is equal then to the concentration of calcium and the concentration of sulfate ions. And look, we have these things, calcium and sulfate. Plug those in. Okay, and we get 2.6 times 10 to the negative 6. Okay, we're almost done. We now have to compare this value to the given KSP. Right, so let's go back to yellow. If our given KSP from the question, you can look back. Let's do that. Let's toggle back. KSP is 2.4 times 10 to negative 10. 2.4 times 10 to the negative 10. Okay, quite low. Double check. No, it's not. It's negative 5. Okay, negative 5. Now we're going to compare QSP. And KSP. And here we can see that QSP is lower, right? The smaller number, 2.6 times 10 to negative 6 compared to 2.4 times 10 to the negative 5. So because we can say that it's QSP is less than KSP, we therefore say it is unsaturated. And then to specifically answer the question, therefore, again, more salt can dissolve without a, that's how I write short form for precipitate, without a precipitate forming. And that's it. You're done. All that to figure out, yeah, you can add more salt. Okay, done. Did that match roughly? A bit off here, but essentially that's it. Okay, so this is your home fun. Hopefully this helped. Post any questions. Remember, you need to practice this stuff. I'll continue posting. Let me know if you have any questions. Again, hope this helped.